Hello everyone, we are Team ERA from SRN MEHTA CBSE School. We are thrilled to present our project ERA in front of you all. This project ERA, it was a settlement designed by the students. Why the name ERA? The name ERA signifies Mother Earth. The literal meaning is the tribute to Mother Earth even in the space. We have even selected a Sanskrit slogan, Chandramam Prithviyanam Mangala Kaksha Karmatam, which translates to the moon's path, Earth's vehicle, active in Mars orbit. Location. Keeping in mind about some of the factors like distance, cost, duration, gravity, space debris, and many of them, we concluded that lower Mars orbit would be the best location as it provides long-term habitation facilities.
Our colony features 6 torus-shaped rotating habitats and a central cylindrical unit. The topmost and bottommost sections serve as docking ports, which are divided into 3 sections, one for cargo, one for passengers, and the other one for emergency evacuation. The topmost torus is the agricultural zone in which various agricultural activities will be performed. The second torus will be the industrial zone in which the raw materials will be converted into the processed ones. And in the human settlement zone, the actual 9,000 population resides. In the education and recreation zone, various educational institutions and other leisure activities will be provided. Coming to 2 small toruses, they will be having additional facilities for laboratories and waste management zone. Now coming to how are we going to generate artificial gravity inside the colony, we will be rotating the toruses independently. This will create something called a centrifugal force. This centrifugal force will pull the objects outwards and will mimic the pull of gravity, thus creating artificial gravity inside the colony.
As we know that our civilization consists of 4 larger tori and 2 smaller tori, the area of the large tori will be 125 acres and the small tori will be of 50 acres. In base materials, we will be using aluminium 2219 and Kevlar. But in radiation shielding, we will be using titanium, tungsten and borated polyethylene. To maintain our structure, we will be using silica gel as our adhesive. In active radiation shielding, we will be using a magnetic field surrounding the structure would do the job, deflecting most of the radiation in space and acting as a virtual shield. We have also developed a very unique way to handle space debris. Energy generation. The energy demands of our civilization will be met by solar energy obtained by solar panels. In our settlement, we will be using a specific type of solar panel arrangement called 4-junction cells. This arrangement will be able to achieve an efficiency up to 47% and produce up to 3 million kilowatt-hour per day of energy. In energy storage, we will be using 2 methods, mainly molten salt technology and gravity-based energy conservation.
Minimizing Coriolis force. Due to the rotation, a force is generated which is called Coriolis force, due to which the deflection is caused. Therefore, it's very necessary to minimize it. Here are some following measures which can be adopted to cure the above problem. We can increase the radius of the colony and the pathways can be designed along with the radius of torus to curtain diffraction. Propulsion system. Propulsion system. In this system, we have used thermal propulsion. A thermal propulsion system has heat propellant to produce high-speed exhaust creating thrust. Heat comes from a reactor or solar energy. The benefits of thermal propulsion system is fast traveling between planets and less fuel is needed. It is very important to create a backup lunar base in the moon in order to facilitate communication. Our team has determined that the Shackleton crater, which is situated in the south pole of the moon, is among the best places for the backup base. However, there are many problems which we face once we inhabit there, and we have come up with solutions in order to avoid those problems. The most unique and the most preferred way of public transport is magnetic levitation. There are 2 varieties of magnetic levitation. An additional detail in our footpaths is the use of piezoelectric tiles which generate energy when somebody walks on it. This is called piezoelectric energy harvesting. Now once we inhabit the space colony, there are many problems which might arise and we have created some emergency systems, protocols and backup systems in order to avoid this. For example, the crop failure might occur on large scale. At this time, emergency food rations will handle the situation.
Resource gathering. We'll gather resources from Mars and its moons for our colony, that will help life support, energy and construction. The important resources for human survival are mentioned here. As our colony is located in lower Mars orbit, we'll be extracting water from Mars, where there are sources of water like polar ice caps, subsurface ice, underground water, etc. by using technologies like drilling technology and thermal extraction. Before this, the water needs to be purified as the soil is rich in perchlorate chemical compounds which is very toxic. We'll be using methods like fractional distillation, electrolysis and condensation. Food. Our colony has total area of 600 acres for 9,000 population, and for agriculture we'll be using 45 acres with the use of vertical farming. We'll be using methods like aeroponics, hydroponics, LED lights, algae farming, mushroom farming, along with lab-grown meat in our civilization.
Atmosphere. There are three major gases we need in atmosphere: nitrogen, oxygen and carbon dioxide. Nitrogen extracted through cryogenic distillation from Martian atmosphere, and oxygen can be produced from Martian water using electrolysis. Carbon dioxide will be extracted from Martian atmosphere through cryogenic separation, and it is also released by humans. Pressure is kept between 30 to 60% of Earth's sea level.
In space, relies on radio waves and satellite links. Antennas convert electric current into radio waves that are broadcast in all directions. The sensors automatically turn where there is more radio frequency, and also there are poles located after every 1.5 km to 2 kilometers. Thermal systems. Usually in space colonies and spacecraft, we use MLI, that is multi-layer insulation, which protects from harmful radiations and temperature fluctuations. By layering of MLI helps in creating barriers and reduce heat exchange. Day and night simulation. Here we'll be using LED system in which it regulates the color of sunrise, afternoon and so on. For example, the glasses will be slightly tinted yellowish orange during day. We can also use electrochromic glass with UV filtering property.
In our space colony, we have different zones for different seasons. For winter, we have lowered the temperature and we have used dry ice and INA protein for snow and cloud formation. For rainy season zone, we have used INA proteins for cloud formation and rainfall. For waste management in our space colony, we have different processes for solid waste, for liquid waste and for gaseous waste. First we collect all the waste and we separate water waste and solid waste. Water waste is sent to water treatment plant and it is sent to the inhabitants after purification. Dry waste is heated and gas is collected and sent for fractional distillation, and there the gases are separated. And dry sludge is sent to bioreactors where fertilizers and fuels are created.
On Earth, for every 1,000 people, we have 3 medics, but in our space colony, we will be having 35 medics per 1,000 people. The various problems that we'll be encountering in health will be cured, and they can also be prevented through various methods such as AI-powered real-time diagnosis, health checkups, health camps, etc.
Revenue making. We can make revenue by various things like transportation services, research and innovation, resource supply, tourism and resorts, franchising and retail, intellectual properties, collaborations. Costs. The total cost will be around $1 to $1 trillion by adding all our expenses. We can take help from union member countries, private companies, big organization system. Our education system have 4 stages: kindergarten, elementary school, secondary education and graduation. We believe in theoretical knowledge and practical skills is the key for preparing students for both academic achievement and life in space. In our space, both robots and human teachers will teach the students. Psychology. People living in space may experience psychological issue. To address them, we had give psychiatric support. Even we have conducted some recreational activities, etc. Entertainment. In our space colony, we are providing cinema, sports, refreshing activities as some of the entertainment. Cinemas. 9 dBS cinemas will feature motion chairs and video headset will be provided. Sports. Both anti-gravity and gravity sports will be conducted and it will be telecasted live on TV. Refreshing activities. A variety of recreational activities will be conducted. Tourism. We will provide gravity and anti-gravity game zones, amusement parks, sports stadiums for gravity and non-gravity games where people can see live matches in the stadium. Artificial hill station and resorts. Space-themed cafes and restaurants. Space and star viewing spots. Thank you.
Revenue making. We are going to make revenue through transportation services, Earth to space travel, and internal transport within the space colony, research and innovation, scientific research, technological development, and industrial growth. We are also going to make revenue through resource supply and energy production, mining, and selling space resources to the Earth, tourism and resort, space tourism, resorts and entertainment, franchising and retail businesses, franchises, and e-commerce in the space, intellectual property, royalties from patents and licensing space innovations, collaborations, public-private partnerships, and international research collaborations. Cost. The total cost is coming up to $1 to $1.2 trillion by adding all our expenses. We can take help from the all UNO member countries, see contribution from UNO members presenting the initiative as a global benefit. Private companies attract investments from large corporations emphasizing potential returns. Big organizations partners with international organizations and NGOs for funding and expertise. Government contributions request government to allocate a percentage of their budget for this project. Public and private partnerships, from joint ventures to pool resources and share risks. Crowdfunding, launch a global crowdfunding campaign for individual investments.